on there. And what we're going to be doing today, we're going to go and use the calculator method for this, just because it's actually two separate combination problems you have to deal with. So for this example, it says in December 2009, the United States Senate consisted of 60 Democrats and 40 Republicans. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? So again, we're forming a 5-person committee, but we have a limitation that 3 of them must be Democrats and 2 must be Republicans. So what this means is we actually have 2 sets of values for each variable. For our Democrats, we have an N value and an R value. And then for our Republicans, that should be a P, we also have an N value and an R value. Because we're making a 5-person committee, but they actually give us a limitation on the size or on the amount from each group that we have to choose from. Because if we were to ignore that we had Democrats or Republicans, we just said 100 senators, and we need to make a 5-group committee, that would be just like what we'd been doing before, where we had a single one. But in this case, we actually have 2 separate groups that we need to choose from. So for our Democrats, we're told that we have 60 Democratic senators. So our N for the Democrats will be 60. And then for this group, we're told that we're choosing 3 from that group of 60. So our R will be 3. Then on the Republican side, how many are we choosing from on the Republican side? How many are there in that group?
40.
There are 40. And then how many are we choosing? 2. So we have 2 separate pieces here. So I'm actually going to set these up as our NCRs, where the first one that we have is going to be 60C3, and our second one is going to be 40C2. Now, these 2 pieces are going to give us our number of possibilities when we're choosing 3 Democrats from 60. This one's going to give us our number of combinations where we're choosing 2 Republicans from 40. But those do interact with each other. They're not just completely separate from each other, because this committee does have to be put together. So we actually need to take into account how many different ones there are based on if we choose one group of Democrats. We have to make sure that we count for all of the other groups of Republicans that could be paired with them. So this actually goes back to the fundamental counting principle, where we actually multiply these by each other. So we're going to do 60C3, and then we're going to multiply that by 40C2. So in our calculator, turn on the light so we can actually kind of see this. In our calculator, just as a refresher on how to actually do this, if we take our 60 and type it in, so I'm going to type in 60. I know it's kind of hard to read. If I want to get the NCR function, I'm going to hit math. I'm going to go over to PRB, and then if you notice, the second and third ones, second is NPR. That's what you use for permutations. The third one is NCR. That's the one we're going to be using here. So I'm going to do 60 NCR, and then on the R side, I'm going to put the 3. And that's going to tell me that for those Democratic groups, there are 34,220 possibilities. I'm going to do the same thing with my Republican group. So I'm going to do 40 NCR2. That's going to tell me that there's 780 possibilities choosing from those. Now, these do interact with each other, because for every combination in 34,000 out of these 34,220, there are 780 different options for each of those. So that means that we need to multiply them together. And this is going to give us a total number of combinations of 26,691,600. So what I'm actually going to do is I'm actually going to write down what the numbers were down here below. So this is 34,220 multiplied by 780. So that's going to give us 26,691,600 combinations. So I'm going to write those committees, which is quite a few. And that'll be what we're looking for. What questions do you have about this? It's the same as what we were doing on Thursday. Just now we are actually we have two separate ones we have to multiply by each other. 10 is actually exactly the same as this. No questions? Okay, so on 10, what I'm going to do, if you want to do this and you want to check with me to check your understanding, yes, I want you to do that. So Devin, if you think you need another example, I would do it. If you are somebody that thinks you're ready to go ahead and finish up the assignment from Thursday, I'm also okay with that option. So if you're somebody that wants to go ahead and get started finishing up the assignment, I would go with that. If you are somebody that wants that extra example on the end, I would do that and then come and check with me on the answer. All right? Okay, I need to go ahead and add a piece to the assignment from Thursday because I actually cut out most of the piece. So the piece I want you to add, it's only going to be a couple of problems. Add 48 and 50 to this. Okay, so 48 and 50 are new to that. So if you were somebody that already finished it, just go ahead and do that on a piece of paper and turn it in. But 48 and 50 are both like this example up here. So this is new. This stuff was all here last on Thursday. This is the piece that's added to it. So it's the section that's right before the 52 on there. Any questions? All right, you can go get started on that.